Okay, welcome back. Good morning to all. This internet services, again we're discussing the web services. Web services allow exchange of information between applications on the web. Using web services, applications can easily interact with each other. Next is your www, World Wide Web, is also known as the W3. It offers a way to access documents spread over the several servers over the internet. And these documents may contain text, graphics, audio, video, hyperlinks, and the hyperlinks allow the users to navigate between the documents. Next is your video conferencing. Video conferencing is another service through internet. Or video teleconferencing is a method of communicating by two-way video and audio transmission with help of telecommunication technologies. So these are about the internet services. Now come to the transmission mode in computer network. How many types of modes are available in the transmission? So transmission mode means transferring the data between two devices. It is also known as communication mode. Bus and networks are designed to allow communication to occur between individual devices that are interconnected. There are three types of transmission mode. One is a simplex mode, another one is a half duplex mode, and the full duplex mode. So first is a simplex mode. In simplex mode, the communication is unidirectional, as on a one-way street. Only one of the two devices on a link can transmit, the other can only receive. The simplex mode can use the entire capacity of the channel to send data in one direction. Example, keyboard and traditional monitors. The keyboard can only introduce the input, the monitor can only give the output. That means in simplex mode, let's discuss, the communication is unidirectional. Right? It's not the bidirectional. That means only unidirectional. That means look the speaker, that means data move from this system to this system, not the reverse. If there is a reverse process is possible, that is the bidirectional process. So it is purely unidirectional process. As a one-way street, right? One-way street. Only one of the two devices on a link can transmit, the other can only receive. So best example, the simplex mode of communication is that either through the keyboard you can transmit the data to the system, but reverse, is that possible to receive the data from the monitor through the keyboard? No, this is a simplex communication. Right now, simple monitor can only give the output. There is no way to receive any input directly by the monitor. So that is the simplex mode of communication. Next is a half duplex communication. In half duplex mode, each station can both transmit and receive, but not at the same time. When one device is sending, the other can only receive, and vice versa. The half duplex mode is used in case where there is no need for communication in both directions at the same time. The entire capacity of the channel can be utilized for each direction. Clear? So best example is walkie-talkie. In walkie-talkie, when one person starts to send the data, other person only receive the data. At the same time, he or she not able to talk with that other people. Right now, this is a one-way communication. Right? So the best example of the walkie-talkie, in which message is sent one at a time, and messages are sent in both the directions. That is the half duplex mode. Next is your full duplex mode. In full duplex mode, both stations can transmit and receive simultaneously. In full duplex mode, signals going in one direction share the capacity of the link with signals going in other direction, and this sharing can occur in two ways. Either the link must contain two physically separate transmission paths, one for sending and other for receiving, or the capacity is divided between signals traveling in both directions. So best example of full duplex mode is your mobile phone communication. That means at a time both person can communicate with each other. That is the full duplex mode. So next is your transmission. It is the data transmission, parallel data transmission. So in your parallel data transmission, when data is sent using parallel data transmission, multiple data bits are transmitted over multiple channels at the same time. This means that data can be sent much faster than using serial transmission methods. The main advantage of parallel transmission over serial transmission are it is easier to program and data is sent faster. Again I am repeating. In parallel transmission, when data is sent using parallel data transmission, multiple data bits are transmitted over multiple channels at the same time. This means data can be sent much faster than using serial transmission method, because here for each bit there separate lines are reserved for each bit. That means you are sent the 8-bit data. That means there are 8-bit lines are present here. Suppose this data is to be sent by the sender to the receiver. That means 0 will send to this line, 1 is will send to this line, 1 is to. So in this way, all the 8 bits are transmitted to separate lines. So its speed is much faster than the serial transmission. Clear? But here demerit is that, what is the demerit? Now demerit is that if there is any problem, because the width of this parallel cable is parallel cable, there is much we are having the much width compared to the serial cables, or this is a PATA cable structure, and that is the SATA cables. These are parallel transmission cables. Here, suppose a single wire is damaged, or suppose single wire is a problem in the single wire, then there are no possibilities to communicate your data to the receiver right now, because 8-bit lines are reserved for this for this all 8 bits. If any problem happen with this any of line, then the entire data is stopped for to transmit from sender to the receiver side. Clear? Next come to the serial data transmission. In serial data transmission, when the data is sent or received using serial data transmission, data bits are organized in a specific order, since they can only be sent one after another. The order of the data bits is important as it detects how the transmission is organized when it is received. So look the picture. In the serial transmission, there is only a single line. All the bits are transferred by only sent one after another. That is the serial transmission. Here the process is little bit slow, but the transmission process. But here the data transmitted is and the safe, that means in safe manner, because the width of the serial cables, SATA cables, is much thinner compared to the PATA cables. So there is no maintenance problem. So in the serial data transmission, data will be transferred one after another. So this serial data transmission can be divided into two parts. One is just asynchronous, another one is just synchronous. In asynchronous serial transmission, data bits can be sent at any point in time. Stop bits and start bits are used between the data bytes to synchronize the transmitter and receiver and to ensure that data is transmitted correctly. Though it is asynchronous. What is asynchronous? That means it is not synchronous. That means there is time gap between each packet is not the same. Synchronous means the gap between each packet should be same. Right now, though the time gap is not the same in asynchronous case, so that is a start bit and stop bit is there. Right? When the receiver receiving the stop bit, that means it will confirm that this data packet now is end. So that's why the start and stop bit is attached with in case of the asynchronous serial transmission. The advantage of using the asynchronous method is that no synchronization is required between the transmitter and receiver devices. It is also a more cost-effective method. Disadvantage is that data transmission can be slower, but this is not always the case, right? Because though it is not synchronization, there is no synchronous clock is required to maintain this synchronization process. Next, come to the synchronous serial transmission. Data bits are transmitted as a continuous stream in time with a master clock, and the data transmitter and receiver both operate using a synchronized clock frequency. Therefore, start bit and stop bits and gaps are not used. This means that data moves faster and timing errors are less frequent because the transmitter and receiver time is synchronized. There is a clock. We synchronize the start and synchronize the timing between the transmitter and receiver. So there is no stop bit, no start bit is required because all the packets are moving in the proper timing gap, proper accuracy, and between the devices. So in comparison with asynchronous serial transmission, this method is usually more expensive. Okay. So thank you to all. This is all over about your chapter number 3. So in the next class, we are going to discuss about chapter number 4. So thank you to all.